Hi guys, this is Miss K. Obviously, I'm not there today. I'm feeling a little under the weather, but I wanted to try to send you a video to help you get through today's lesson so that you would feel prepared for hopefully when I'm back on Wednesday. If you are watching this video right now, that means you just went through the warm-up in class. The way that I'm going to run this video, hopefully you can follow along with me. And then if there are times where you need to do some work, I'll say go ahead and pause the video, and then get your work done on your packet. And then when you hit play again, we'll actually work through the answers. So I'm really hoping that you use this video to your advantage. Don't just watch it straight through and copy down work. That's not going to help you actually learn what we're doing in class today. Really try to stick with me. And if I ask you to pause to do some work on your own, go ahead and follow through with that so you can see if you are learning with me. Okay, so for the warm-up, you were asked to look at a graph and answer the questions on below, which is on the screen right now. So you were looking at a graph of the miles driven versus the gallons of gasoline in a tank of car, in a car's gas tank. So the gasoline usage, you can see, started up here. That's when the tank was full. And then as he or she drove, the tank or the gas depleted for that trip. So we just went ahead and asked some questions. What is the dependent variable? What is the independent variable? Writing is a function of statement, and then figuring out why are these points connected, whereas yesterday in the example, they were not. So if you already went through this in class, you can kind of shift forward. If you want to review one more time with me, here we go. The dependent variable for this graph is the gallons of gas in the tank. Again, the dependent is always your y variable. It's on the y-axis of your coordinate plane or of your graph. And you can see if you look here, gallons in tank refers to the gas that your car has. The independent variable is going to be the miles driven. So again, I control the miles that I've driven in my car. As the miles increase, that gasoline tank is going to start decreasing because I'm using up the gas. So when I write is a function of statement, I need to go ahead and say the amount of gas or the gallons of gas in my tank is a function of the miles driven. Remember, it's always y is a function of x. So that dependent is a function of the independent variable. So the gas in my tank is a function of the miles driven. So then let's talk about why are these points connected? If you think back to yesterday's example, we said that you can't buy a half of a bathing suit. So in order to connect this line, we had to somehow have a continuous function, something that didn't have to start and stop. And a lot of you said, well, time isn't on the x-axis. And that's true because time would continuously be moving forward. So of course we'd have a line. But here, if you think about it, miles driven, it's not time, but my car is continually moving. So as I move forward, I can go a quarter of a mile or a half of a mile or 5/8 of a mile or whatever the case may be. It's not like I start my car and then 1 mile, 2 miles, 3 miles. So if you think back to yesterday, it was buy one bathing suit, buy a second bathing suit, buy a third bathing suit. That's why we did not connect those points. However, here, going to be a continuous line because you can drive partial miles. So remember, yesterday was not connected because you couldn't buy a partial bathing suit, but today this line is connected because I can drive partial miles. All right, so that takes care of our warm-up. Let's move right along into the homework. Before we get there, I want to look at page 7 just to wrap up. I know the bell rang in most of our classes yesterday, right as we were kind of finishing that discussion. But if you turn back to page 7, you'll notice or remember that we were talking about bathing suits costing $20 and that one-time fee of $30. And a lot of you told me that when you put down your table and went to graph it, look at these values one more time and make sure they match what you had on page 7. A lot of people tried to put 100 here next to 2 bathing suits. And that's kind of where we ended in some of the classes. This can't be 100 because the one-time fee is just that. That $30 for shipping was only assessed one time. It doesn't matter how many bathing suits we bought. it was a $30 processing fee. So that's not going to be put on, or that's not going to be added to every single bathing suit. So from after our $50, that represents the $20 bathing suit plus the one-time fee. As we add on swimsuits, you're only adding $20 each time. And then again, if you look at our graph here are all points that are not connected together with a line, because again, I can't buy a part of a bathing suit. Those last three questions that we never made it to yesterday, what does the 0.6 actually represent? It means the total cost for 6 swimsuits. Remember, 6 was the independent variable, that X of your X and Y coordinate. 6 represents 6 swimsuits, costing the Y coordinate was the cost. So is $150. In number 7, I've talked about that a lot. You can go ahead and read it. And then in number 8, for the point whose coordinates are 6, 150, which number represents the independent variable? X is always independent, Y is always dependent. So in an ordered pair, you have your X value of 6. So X is, or the independent value is 6, and the dependent value is going to be 150. So that kind of wraps up where we were ending yesterday. Now we're going to go ahead and we're going to look at your homework. So go ahead and switch to page 8. And if you're reading Yoda right now, check yourself. You must. Before wreck yourself, you do. I'm going to go ahead and put this up. This would be a great time to pause the video, take a look at your answers versus my answers. And if there's anything you have questions about, you can definitely ask me tomorrow when I'm back. All right, so hopefully you had a chance to look at those homework answers. If you are starting the video again, you can see that it asks you to turn to page 9 in your packet. So we're going to take a couple of notes together. On page 9, this is actually our introduction to function notation. And you can see I'm going to move this page 9 out of the way for you. Yesterday's problem about the swimsuits, well, we're coming back to it. We just kind of reviewed, so I'm not going to read that all again. But when we go to look at function notation, there's a special way that we write it. Let's say that you wish to make several similar statements like these. The total cost of ordering 2 swimsuits is $70. The total cost of ordering 5 swimsuits is $130. The total cost of ordering 7 swimsuits is $170. So we use a special mathematical shorthand that we actually call function notation. The statement, the total cost of ordering 2 swimsuits is $70, will actually be written, and you can see it right here on the screen, T of 2 equals 70. So that's how we say it. The total of purchasing, so the total cost for purchasing 2 swimsuits is, that's our equal sign, $70. So this way that you see it written down is the way you are going to always write standard function notation. So this total cost of ordering 5 swimsuits would be T of 5 equals 130, and the cost for buying 7 swimsuits would be written as T of 7 equals 170. So please make sure you understand, and this part's really important. You might want to go ahead and put a star. Oh, and that's not going to work. Let's see, you might want to go ahead and put a star on next to your paper. The notation T of 2 does not mean T multiplied by 2. This is not a coefficient and a variable that we're talking about. In this context, it represents the total cost of ordering 2. So when you have function notation, the actual way that we show it looks like this. F of X is equal to Y. And so you can see my X variable, the independent variable, is going to go right here next to the whatever is outside that function of. And then our dependent variable, or that total cost in this case, would go next to the equal sign. All right, so we're going to move on. And in order to continue, you will have to start the next video.